So in this video we're going to go over caching. So let's go over some terminology before we actually go over what a cache is. So a cache hit is basically a successful search of some data in a cache. Cache miss is an unsuccessful search of data in a cache. Latency is a delay in processing some data and information. Metadata is data that stores information that describes other data. And then throughput is just the rate of production. So what is a cache? Well, a cache is a data storage that we can use and implement via hardware or software. In terms of hardware, it's something that's close to the CPU so that we can easily access memory. In terms of software, we can look at it like a web cache, which grabs recent information on various sites that we visited. So it works very similar to a hash table in the sense that it has a hashing function, but the collisions are basically leads to data overwriting. What does that mean? It means that when we add something to our cache and we find that the bucket is already full of something else, what we do is we replace the old data with the new data. It's small in terms of size. This allows us to bypass latency. As you guys remember here, this allows us to speed up production because we're actually overpassing the delay in processing. So it's like we have no delay in processing data and information. So this increases our production. So in terms of hardware, we have this thing called the CPU cache, which allows us to speed up access to data in the main memory. Allows us to easily and quickly run calculations through our ALU. So there we go. We'll take a look here really quickly. The CPU cache. So here we go. Oops. Let's take a look at this example here. So we have our core processors over here, and then we have our cache down here, which is easily accessible to each one of these and allows us to speed up production. Here's another example where we have two caches here. I'm not much of a hardware guy, but there we go. Here's a more simple picture here where we have two caches here and then the CPU is here. Notice how the caches are very close to the CPU so that it can perform its arithmetic logic and whatnot. So it makes it faster and faster for us to, or it's better and better, and it makes us faster in order to process things with our computer. And here, hold on one second, let's go back to the presentation here. So we also have this thing called the web cache, which stores responses from visitor websites. This allows us to reduce bandwidth and allows us to increase the speed of our connectivity with these web pages, so we don't have to keep waiting for responses from these websites over and over again. People tend to get the terms of buffer and cache mixed up. A buffer stores basically metadata, and a cache stores data. So if you guys remember, buffers store metadata. What does that mean? It basically means that buffers store the information that describe and kind of lay out the details and rules and the regulations of other data, while cache just stores basically raw data and information. Here are some references that I used. So I looked up cache via Wikipedia, and I also looked up the question: what's the difference between a buffer and cache in memory? I didn't look it up for Linux specifically, but basically the bottom line is this is what I found on that forum. You can take a look at that forum, verify it. This is the short, concise version. I forgot who exactly made it easy, but somebody made it really easy and simple. So I hope you guys learned something.